Okay, here's the Chem 1 version of the Lewis structure with double bonds. So again, we would start by writing out a formula, which we already have our formula written for us. We would count our valence electrons, 4 from carbon, 1 from each hydrogen, 6 from oxygen, total of 12 valence electrons. We would determine who goes in the middle. Carbon likes 4 bonds, hydrogen likes 1, oxygen likes 2, carbon's going in the middle. And we would arrange all of our other atoms around them. So we have something that looks like this. We draw in our bonds between each, and then we put dots on anything within groups 14 through 18 that doesn't already have 8 electrons. So we're to this structure here. We then count our electrons, 2, 4, 6, 8, 10, 12, 14. If there are too many electrons in our structure, like there are in this picture, we simply erase 2 from the center atom. We erase 2 from another atom, one of the terminal atoms, and keep in mind the ones that we usually look for in order to give the double bond: sulfur, phosphorus, oxygen, nitrogen, and carbon. And then we replace the 4 electrons that we erased with another bond. So now we have 2, 4, 6, 8, 10, 12. 12 electrons. This is an appropriate structure. Also, a quick review of the electronegativity information from yesterday, just to try to make sure that we still understand how these things come into play. If we're looking for bond polarity, we need to consider the electronegativity difference between each of the atoms that are involved in a bond. So here we have a carbon bonded to a hydrogen. Carbon's electronegativity is 2.55. Hydrogen's is 2.10, so that's a difference of 0.45. That's above 0.4, so this would be a polar bond, and it would point, the dipole would point toward the more electronegative atom. So we would have something that looks like that. And then we look at oxygen, 3.44 minus 2.55. Again, the 2 atoms involved in the bond, carbon and oxygen. Difference of, well, if I can math correctly, I think that's 0.89. That is also a polar bond. This time it's pointing out away from the center atom because oxygen is more electronegative than carbon. These little dipoles here would show us the polarity of each individual bond, but in order to figure out the polarity of the molecule overall, we also need to consider its shape, which is actually the next lesson, so don't freak out yet. But quick review from Chem 1, we know that if we have 3 things that are spread out equally, because there's no lone pairs on our center atom, that winds up being a trigonal planar shape. We have dipole pointing in, dipole pointing in, dipole pointing out, which means overall the electrons would all kind of concentrate down here. This is our side that winds up being a little bit negative, and up here we wind up with a side that's a little bit positive. Overall dipole moment is pointing down. Hope that helped.